This is a continuation of our astronomy unit. This lesson is introducing the solar system. Imagine a place where the sun shines 11 times brighter than it does on Earth. How could you keep anything cool there? Engineers had to solve just that problem when designing the Mercury Messenger spacecraft. In 2008, this spacecraft began to visit Mercury, where temperatures can reach up to 370 degrees Celsius. Engineers designed a sunshade to protect Messenger's instruments. It's made from ceramic fabric. The fabric, made of elements such as silicon, aluminum, and boron, is resistant to heat. It reflects most of the sun's heat away from the Messenger spacecraft, keeping all the instruments at a comfortable room temperature of about 20 degrees Celsius. So what makes up our solar system? Mercury is just one of the many objects that make up our solar system. Our solar system consists of the sun, the planets, their moons, and a variety of smaller objects. The sun is at the center of the solar system, with other objects orbiting around it. The force of gravity holds the solar system together. Distances in the solar system. Distances within the solar system are so large that they cannot be easily measured in meters or kilometers. Instead, scientists often use a unit called the astronomical unit. One astronomical unit, or AU, equals the average distance between Earth and the Sun. That is approximately 150 million kilometers. The solar system extends more than 100,000 astronomical units from the sun. So you can see in this picture where one astronomical unit represents the distance between the Earth and the sun. The sun. At the center of our solar system is the sun. The sun is much larger than anything else in the solar system. About 99.85% of the mass of our solar system is contained within the sun. Despite being more than 1,000,000 times the volume of Earth, our sun is actually a very ordinary mid-sized star. Using telescopes, we see stars that have volumes 1,000 times greater than our sun's. It turns out to be a very good thing for us. Large stars burn out and die more quickly, but our sun will last for 5 billion more years. So let's do some converting of units. To convert from an astronomical unit, an AU, to kilometers, you can multiply the number of astronomical units by 150 million. So let's try some calculations. Mars is 1.52 astronomical units from the sun. About how many kilometers is Mars from the sun? Answer this question in your note sheet. And then, if you know an object's distance from the sun in kilometers, how can you find its distance in astronomical units? Please write a complete sentence answering this question. There are a number of other objects in our solar system besides the sun. There are many different objects in our solar system, so how do we decide what is a planet and what isn't? In 2006, astronomers decided that a planet must be round, usually by its own gravity, orbit the sun, and have cleared out the region of the solar system along its orbit. The first 4 planets are small and are mostly made of rock and metal. The last 4 planets are very large and are mostly made of gas and liquid. Like Earth, each planet has a day and a year. Its day is the same time it takes to rotate on its axis. Its year is the time it takes to orbit the sun. we're going to look at a number of the basic facts about the planets in our solar system, starting closest to the Sun with Mercury. Mercury has a diameter of 4,879 kilometers. It is approximately 0.39 astronomical units from the Sun. It takes 87.97 Earth days to orbit the Sun, and it doesn't have any moons. Next is Venus. Venus's diameter is very similar to that of Earth. It is 0.72 astronomical units from the Sun. Its orbital period takes 224.7 Earth days. And again, Venus has no moons. The third planet from the Sun is Earth. Again, its diameter is very similar to that of Venus. Its distance from the Sun is 1 astronomical unit. And as we already know, it takes 365.26 days in order for it to make one complete orbit around the Sun. We also have one moon. The next planet is Mars. Mars' diameter is 6,794 kilometers. Its distance from the Sun is 1.52 astronomical units. It has an orbital period of 687 Earth days, and it has 2 moons. These are the first 4 planets, also known as the terrestrial planets. The next farthest planet is Jupiter. Don't forget that between Mars and Jupiter is the asteroid belt. Jupiter is the largest of our planets, with 142,984 kilometers for its diameter. It is 5.20 astronomical units from the Sun. Its orbital period is 11.86 Earth years. And Jupiter contains the largest number of moons with 67. Some of those moons are thought to have contained liquid water on them and possibly volcanic activity that would keep liquid water from freezing at least near the volcanic regions. The next planet is Saturn. Its diameter is 120,536 kilometers. It's 9.55 astronomical units from the Sun. Its orbital period is 29.47 Earth years, and it has 62 moons. Uranus has a diameter of 51,118 kilometers, 19.19 astronomical units from the Sun. Its orbital period is 83.75 Earth years, and it has at least 20 moons. The last of the planets that we're going to talk about is Neptune. Neptune has a diameter of 55,528 kilometers. It is 30.07 astronomical units from the Sun. Its orbital period is 163.72 Earth years, and it has at least 13 moons. These last 4 planets are known as the gas giants because they're mostly made of gas. Outside of those planets are also the dwarf planets. The dwarf planets are Pluto, Eris, Ceres, Makemake, and Haumea. It's important to realize that these dwarf planets are no longer categorized as planets. Some of them, many of them have always been considered dwarf planets, but they're not considered planets because they have not cleared their orbital period. They may be large enough to be considered planets, but their orbit is not cleared. There is other debris in the way. One way in which I always remembered the planets from beginning to end, this includes Pluto in there as well, so you get to remember one of the dwarf planets. I always used the mnemonic device, "My very earnest mother just saved us 9 pennies." The first letter for each word represents the letter for each of the planets. So, my, M stands for Mercury, very, V stands for Venus, so on and so forth. For many years, Pluto was considered the 9th planet in our solar system, but Pluto shares the area of its orbit with other objects. Pluto is now considered a dwarf planet. A dwarf planet is an object that orbits the Sun and has enough gravity to be spherical, but it has not cleared the area of its orbit. There are 5 known dwarf planets in our solar system. I just went over those 5. Again, they are Pluto, Eris, Ceres, Makemake, and Haumea. As scientists observe more distant objects, a number of dwarf planets may be identified over time. So the number of dwarf planets we have in our solar system may increase. Except for Mercury and Venus, every planet in our solar system has at least one natural satellite, or moon. Earth has the fewest moons with just 1. Jupiter and Saturn each have more than 60. Some dwarf planets also have their own natural satellites. The solar system also includes many smaller objects that orbit the Sun. Some are called asteroids. They are small, mostly rocky bodies. Many asteroids are found in an area between the orbits of Mars and Jupiter. Comets are another large group of solar system objects. Comets are loose balls of ice and rock that usually have long, narrow orbits. So how did the solar system form? We're going to specifically take a moment and we're going to look at the theory of a solar nebula. I understand that not everyone believes in that theory. I'm not trying to persuade you one way or another. What I do want to do is I do want to take a little bit of time so that you understand what this theory is, and then based on what the theory is, you are better informed to make decisions of your own. So, where did the objects of the solar system come from? Scientists think that the solar system formed about 4.6 billion years ago from a cloud of hydrogen, helium, rock, ice, and other materials pulled together by gravity. The process began as gravity pulled the clouds together. The cloud collapsed and started to rotate, forming a disk. Most of the material was pulled toward the center. As the material became highly packed, it got hotter and the pressure on it increased. Eventually, the temperature and pressure became so high that hydrogen atoms were pressed together to form helium. This process, called nuclear fusion, releases large amounts of energy. Once nuclear fusion began, the sun gave off light and became a stable star. Sunlight is one form of the energy produced by fusion. Away from the sun, planets began to form as gravity pulled rock, ice, and gas together. The rock and ice formed small bodies called planetesimals. Over time, planetesimals collided and stuck together, eventually combining to form all the outer objects and the inner objects within our solar system. So the picture right here would show that series of events. We want to put this series of events in chronological order as this theory holds. So we would start with a spinning area of gas and dust up in the upper right hand corner. Slowly it would coalesce, so that means that all of the materials would come closer together through gravitational attraction. So 2 would be the next picture. And then some of the other materials, the planetesimals, would form, and some of the other materials would be attracted to them. The orbits of the planets would be cleared, and eventually those planets would have a distinct shape. Again, this is a theory. Theories have supporting evidence, but they are not laws. The inner planets. Close to the sun, the solar system was very hot. Most water evaporated, preventing ice from forming. The bodies that formed in this region were comparatively low in mass. Their gravity was too weak to hold on to light gases such as hydrogen and helium. This is why the inner planets are small and rocky. Again, they are also known as the terrestrial planets. They include Mercury, Venus, Earth, and Mars. The outer planets. At greater distances from the Sun, temperatures were cooler. Ice formed, adding mass to the planets that formed at these distances. As the planets grew, their gravity was strong enough to hold hydrogen and helium, forming the gas giant planets. Beyond the gas giants, temperatures were even lower. Ice and other materials produced comets and dwarf planets in this area of our solar system. So the gas giants include Jupiter, Saturn, Uranus, and Neptune. Also notice that in comparison to our inner planets, our terrestrial planets, the gas giants are much, much larger. Alright, answers to converting our units. Number 1, 1.52 astronomical units times 150 million gives us 228 million. And that would be, the units would be in kilometers. And then the answer for number 2, divide the distance in kilometers by 150 million. If you have any questions over these two converting units questions, please make sure that you see me.